All right, we're back. We're on page 93 of math analysis, still in notes 9. We're still working our way toward the 14 formulas. We got 9 of them down. That's a bunch of, it's sum and difference for, so Euler's formula, first of all, that's number 1. Sum and difference for sine, sum and difference for cosine, double angle for sine, 3 versions of double angle for cosine. Pretty sure that's all the ones that we know so far. Now let's work on half angle formulas. So the half angle formulas, it's a little weird, right? So like if you have pi over 4 is an angle that we know something about, the half angle formula will allow us to take half of that. So pi over 8, we'll be able to find the sine and the cosine of pi over 8. That's kind of the idea. So let's see if we can work out the formulas. They all come from the double angle formulas for cosine, the like weird ones, right? So what I'm gonna do is I'm gonna say that the cosine of 2b, so I'm doing this to make it easier to make the substitution, kind of like in your head. Cosine of 2b equals, let's do the one with cosine, 2 cosine squared of b minus 1. So what I'm going to do is I'm going to solve this again. I did it in the last video at the end for the power reducing formula. So I'm going to add 1 and divide by 2 and end up with cosine squared is 1 plus cosine of 2b divided by 2. Now I'm going to take the square root, but the tricky thing about taking the square root is that you need plus or minus. So cosine of b equals plus or minus the square root of 1 plus cosine of 2 times b divided by 2. Okay. Don't worry about that plus minus just yet. We'll worry about that in a second. Now we're going to make our substitution where we let b equal a over 2. So just replace every b you see with a over 2. And it'll give you the cosine of a over 2 is plus or minus the square root of 1 plus the cosine of 2 times a over 2 is just a. It's like magic. These formulas, like, I don't know, it's crazy. So hold on to the plus or minus idea. We'll come back to it in a second. Well, I mean, it's ruined down here, but plus or minus square root of 1 plus the cosine of a over 2. It feels right to me. It's like cosine should have a plus in the formula because it's like cosine goes with cosine. Let's find the other one for sine. So here we're going to use cosine. So both of them are based on this formula, though. Oh my God, what? They're both based on the double angle formula for cosine. So this one is going to be 1 minus 2 sine squared of b. So this one people have a little more trouble with, so I'm going to show a little extra work. I'm going to add 2 sine squared to both sides and simultaneously subtract cosine of 2b. And then divide by 2 and square root. So sine of b is going to be plus or minus square root of 1 minus cosine of 2b over 2. And then we're going to replace every b that we see with a over 2 because that's our thing. So we're going to get sine of a over 2 is plus or minus the square root of 1 minus cosine of 2 times a over 2 is just a again, and then over 2. Okay, so this plus or minus should be bothering you. So here we go. We got plus or minus, we got plus or minus. Now, cosine of something can't be positive or negative. It either is positive or it is negative. It's not both. Like you don't get a plus or minus. So the way you determine it is you look at the quadrant of a over 2, right? So if somebody asks you to find the cosine of 212 degrees, 212 degrees is in the third quadrant, so cosine and sine should both be negative. So you would choose the negative there. If you were asked to find the cosine of 93 degrees, that's got to be negative, so you'd have to choose the negative. We'll do problems where like you can actually do it. You look at the quadrant of a over 2 for the plus or minus. So you don't get both, you get one, but you don't know which one you're going to get until you know what quadrant you're supposed to be in. And you'll know just by looking. Like it's not This is not something to stress over. People stress over it though, because it's a very scary looking formula. And then the other thing is they look almost identical. It's just that, you know, cosine. So this is how I really feel about it. It's like cosine should get a plus because they go together, whereas sine should get a minus because, like, what is sine doing with cosine? Like, why are they there? But that's how I tend to remember them. And while we're here, let's try to get the sum formula for tangent. Are we doing the sum and the difference formulas for tangent? Holy cow. All right, let's just do it. We're gonna end up, otherwise we'll end up with way too many videos. So let's see. Sum formula. So what is tangent equal? Tangent of x is equal to the sine of x over the cosine of x. All right, so what does that mean for us? Well, that means the tangent of a plus b should equal the sine of a plus b, which in practice, this is how you're actually going to find it usually. You will already have, for some reason, found the sine and the cosine of a plus b. Just divide those. Like if you have numbers for them, just divide them, and you will get the tangent of a plus b. If you don't have numbers, a more direct way to do it is to use this formula. But again, I swear, what you want to do is just use the numbers. So it's sine, cosine, plus cosine. This is why you got to know these. Well, this is like 1/1,000,000th of why you need to know these, but it's still a reason to know them. And then cosine, cosine, minus sine, sine. Okay, so we got this. And then now here's the question. What do we do with this? So I know what we need to do with this because I know what the formula should look like. What I'm going to do is I'm going to, and it's not obvious why you're doing this, like even remotely. I'm going to divide every single thing that I see by cosine A, cosine B. I'm dividing everything I see by cosine A, cosine B. So I'm going to write it out, but I'm probably going to cheat with the copying and pasting. So tangent of A plus, so this is, my spacing on this is already not going to work. Okay, here we go. So I'm going to take, I'm just copying right now. I'm going to copy the numerator here. Let's duplicate u. Okay, I'm going to divide everything I see by cosine A, cosine B. So cosine A, cosine B. Divide by cosine A, cosine B. I could copy and paste that too. If that's what you're thinking, I think that's a good idea. And then I'm going to take everything I see in the denominator and divide it by cosine A, cosine B. I'll get rid of, oh, I forgot the fraction bar. There we go. There you go. Let me delete that. And then we're going to go over, copy and paste magic, duplicate, cosine A, cosine B, and then duplicate u again, cosine A, cosine B. Size of that's like all a little weird there. And then over that. Okay, so why is this spaced out so funny? I don't really know. All right. All right, what are we left with? What do we got? Let's see. So there's a lot of stuff that cancels here, and I'm going to cancel them in orange. So here, I got cosine, cosine, gone. Cosine, cosine, gone. Here we have cosine, cosine, and cosine, cosine. And then here, we don't have anything that cancels. But what are we left with? So in the first one, we are left with sine of A over cosine of A, which is just the tangent of A, and then a plus sign. And then we have sine of B over cosine of B, which is just the tangent of B. So this, by the way, that dividing everything you see by like something is a super useful thing to do when you're trying to verify trig identities. I do it a lot. In fact, if you watch some of the like kind of bonusy videos about those, you probably saw me do it a couple of times because it's just so useful. Like if you need to show that two things are equal and you see a 1 in one of them, it's like make a 1. Just divide by whatever you need to make it happen. It's like I knew that this formula should have a 1 here, which is why I know what to do when I get to that stage. So here I have sine A over cosine A, which is the tangent of A. And then I have sine b over cosine of b, which is going to be the tangent of b. Ah, autocorrect. What are you doing? Stop. B. And then this is formatted kind of weirdly. So I don't know. I don't think I'm saving this. But anyway, that's our formula. Tan A plus tan B over 1 minus tan A tan B. So the way that I remember that is kind of strange, actually. I remember it as there must be a plus sign here. So this was plus, this was plus. I always think there must be a plus sign because if there was a minus sign in the numerator, then when I tried to find the tan of A plus A, which is the tan of 2A, I would get tan of A minus tan of A, which would be 0. Why would the tangent of 2A always be 0? It doesn't make any sense. So there's got to be a plus there, which is a super, super roundabout way of memorizing it. But I think we all just do what we can. Tan B over 1 minus tan A tan B. Okay. All right, so you know what? We're going to finish. So tangent's odd, which means the tangent of negative x is the negative of the tangent of x. I imagine that these are by far the most riveting videos that we've done so far. So if I'm going to find the tangent of a plus negative b, same deal as last time. It's going to be the tan of a. I don't know why I'm willing to abbreviate tangent, but not any of the other trig functions, but it's a fact. Like I'm willing to abbreviate one and not the other. Tan A, tan negative B. All right, properties are going to give us tangent of A, and then the tangent of negative B is the negative of the tangent of B, so minus tan B over 1, so it's minus tan A times the negative of tan B, which is going to be plus tan A, tan B. So our formula here is tan A minus tan B over 1 plus tan A tan B. All right, and this is like a 3,000 hour long video, but the thing that we did with sine of A plus B, cosine of A plus B, we can do that here. And so I just want to show you that. We can do the tan of A plus or minus B equals. So you got to be really careful though. It's going to be the tan of A and then plus minus the tan of B over 1, and then it's minus plus tan A. Do it. A tan B. For some reason, the stylus just like would not write there. So this is how I have them memorized. These, I don't use these as often as maybe I should or something. I don't really know. Sometimes I have to derive them. So I frequently have to go back and think like sine of A plus B has a plus in the formula. So tan of A plus B will have a plus in the numerator. I think that kind of frequently when I need to come up with these. Anyway, definitely ending the video here. Definitely coming back in the next one. I'm gonna do a little more. We're up to 13 formulas, so there's only one more to go. And then once we have that, we'll actually start doing something with them, and that's where it gets way more interesting. So I will see you in the next video.